Okay, so it's recording and I'm going to share my screen with you. So do you have up our lab?
No.
If you go to
Should I open it up, the lab?
Yeah, so if you open up the Google Classroom document that says lab. So it's this one, where it's Geology Virtual Lab.
Okay, yeah, found it.
Okay, so this is going to be the document that you fill in while we do the lab. Did you have a chance to watch these like intro videos?
No.
Oh, I'm just judging you a lot. Okay, well, I'll try my best to fill you in on what those were saying. Okay, so this is the lab. So first I had y'all do like a view walkthrough. I'm gonna choose green gloves because my name's Miss Green. So it's gonna load it up. Okay. And so I'll say start. So this lab, the way, woo! Can I turn off the sound on this? This is so like jarring. Streak is going to be a characteristic of minerals that is going to be slightly different than the observable color. And so it gives us some indication of its identity. I love the sound effects. Okay. So in your lab where it says streak.
So let's go down to the chart.
You'll go to the streak color one, and then for calcite, you'll record what color you see.
Wait, is it for the observable color? No, that's the streak, right?
Yeah, this is for streak.
Okay.
Okay. So I'll put this down. Okay. Oh my gosh. So talc is going to be the softest mineral. So if you can scratch it with talc, that means that whatever mineral you're scratching is less hard than that mineral. Okay. So could you tell if the talc left?
Can you say that again? I didn't hear you.
No, you're okay. Did the talc leave a mark?
The talc is, which one is that?
Hold on, let me show it again. I don't want to do the fingernail. All right, well, when I scratched with the talc, it didn't make a scratch mark.
Okay, so it has no streak?
So streak color is only going to be against the streak plate. Okay. Right now we're trying for hardness. Okay. So for your first table, you're going to record the relative hardness of each object. So the talc, your hardness is going to be 1.
because there was barely any hardness. Is that like, oh yeah, that's a scale, right?
Yeah, so that's the Mohs scale.
Okay.
And so talc is the softest, and so it has a rating of 1.
Okay.
So now we're going to use a fingernail to try and scratch the calcite, which I know is really weird because this is like a disembodied fingernail.
So there's a white mark on there.
Not quite. So I know it's tempting to say that these that were already there are caused by the fingernail, but they've been there the whole time, those two distinct
Okay.
marks. So you'll put that into your hardness table. You'll see the fingernail has a value of 2.5.
Okay.
I love these sound effects. So you can kind of see the difference now, right?
Yeah.
You can see those scratches.
So all I have to put down is just the numbers that they're giving me.
Yes. So for the shriek plate, you'll put into your chart that it has a hardness of 5.5. And I can help with the other objects in just a moment for the hardness. And as you can imagine, as we use these other objects, we can try and narrow down the exact hardness of each mineral since we know the hardness of each object. So when we look close up, after you want to determine whether or not it broke kind of like along a straight plane, or if it kind of fragmented in a very irregular way.
Okay.
So if it's straight along a plane, that indicates cleavage. If it is kind of more scraggly and not so straight, that's going to be an indication of fracture.
So hold on, I'm confused. It wouldn't have cleavage, right? It's fracture.
So this one is kind of, it's kind
Wasn't
of
it the white one, right? Calcite?
yeah. So for calcite, this one is actually going to be cleavage. I know like the magnifying glass like kind of distorts the image, but it is going to be kind of more cubical, if that makes sense, like a long kind of plane. Let me show you maybe a picture of what calcite looks like. So usually calcite is going to look like this.
So it's a cube.
Yeah, so it's a little bit more cubical. So that's going to indicate cleavage.
Do we have a chart for that?
Yes. So if you scroll down a little bit, it'll say record the breakage type, cleavage, or fracture for each mineral.
Okay. Oh yeah, I see.
So for calcite, you'll just put in cleavage. So this will put calcite back together. Okay, so the major categories of luster that we're looking at is going to be metallic and non-metallic. So how would you categorize calcite? Metallic or non-metallic?
Metallic because it's like glassy.
Okay, so it is glassy, but does it look like a metal?
Oh no.
No. So that so that'd be non-metallic, and then you'll say glassy.
Okay.
For calcite. So they definitely misspelled metallic, which is the funniest thing. So did you see the mineral move?
No.
Okay, so you'll go down to the chart that says record if a mineral is magnetic or non-magnetic. So for the calcite, you'll say non-magnetic.
Magnetic, non-magnetic, right?
Correct.
Okay.
Does it look like the iron filings are clinging?
Yeah.
Well, to the calcite. Here are the filings, here's the calcite. Are they moving towards the calcite or onto the calcite?
No.
No. So that's a further indication that it's non-magnetic.
Okay.
So we don't have to add anything else, but it's just another way to check for magnetism.
The iron fillings are the things next to the black stuff, right?
Yes, yeah, these like hairy looking things.
Okay.
So it just means it's still not magnetic. Okay, so this bottle is labeled as unknown liquid. And so in this walkthrough, it identifies it for you that it's acid. And so this is going to be a question in the part that's after the charts.
Okay.
It says, what's the mystery, liquid? You'll say it's acid.
Okay.
So when we take this acid, okay, so when you put the acid onto the calcite, what kind of reaction did you see? I can do
Yeah, I couldn't really see it. It like fizzes.
fizzes, perfect. So what that is from one of the intro videos, is something called effervescence. So effervescence is basically a sort of chemical reaction between acid and something called carbonate within a mineral. So when you have effervescence, it's an indication that there is carbonate within that mineral. And so this will come back up again. I don't know if you remember from last week when you did the sinkholes assignment. They talked a lot about different types of soils and areas that are made up of carbonate minerals. And as a result, they kind of break down when they come into contact with slightly acidic water. And so that's what we're testing here with effervescence. So there is going to be another chart that is going to have you record effervescence.
Yeah, I see it. So would I just put yes for that?
I think yes. Yeah.
Okay.
So you can say yes for calcite. So I think the only thing we have left is the observable color of calcite. So you'll go ahead and describe just by looking at calcite what color it is.
Like a weird white.
Weird white. That's a technical term. Love it. All right, so you tell me what you want to do. Do you want to go ahead and test Mica next?
Yeah.
Okay. So which one of your hardness tools do you want to use against Mica?
It doesn't matter.
No.
So many options I can't choose.
So funny. Well, let's start with talc because we know that's the softest. All right. Did that make a streak?
No.
Nope. So we know that this mineral is harder than 1. So the next one is our fingernail.
So for streak, we put no. No streak.
So for streak, we are gonna keep using these different tools until we can get a streak.
Okay.
And then we'll record what color that streak is.
Okay.
So fingernail didn't do anything. And so we know it is greater than 2.5 on the hardness scale. I'm gonna cheat and tell you that a penny has a hardness of around 3. So it's slightly more than our fingernail. Did a penny leave a scratch?
No.
No. So it's still harder than 3, and then for a nail. Okay, this is going to be slightly more than that. So this is probably going to be like between a 3 and a 5, I'd say, for a nail. Our streak plate, we know from the tutorial, is about a 5.5. So did that leave a streak?
Yeah.
Oh yeah, she's messed up. So we know that is not harder than 5.5. Let me see for glass. So glass puts us probably about, I would say, maybe like a 4-ish. So we definitely know that it is not harder than a 5.5. So for mica, we could safely say it's between 4-ish and 5.5 for its hardness. So let's check out our luster for mica. So does this look metallic or non-metallic?
Metallic?
So
No, not metallic because it looks glassy.
it looks glassy, yeah. So you'll say non-metallic and then you'll say glassy for its luster.
What is it, like what will we observe if it's metallic?
Oh, you will find out. It will look like metal, like bits of metal, like shining. So it's slightly different than this kind of glass-like appearance.
Okay.
All right, so now let's do magnetism.
No.
Did it move towards the magnet?
No.
No. Did the iron filings move?
No.
So you'll say it's non-magnetic. You can check effervescence, hydrochloric acid. So
Happened.
did anything happen?
No.
No. You can check our streak. So you can record the color with the streak.
Like grayish black, right?
Mm-hmm. Mm. So does this look like it's breaking across like straight, not like completely straight, but in some sort of geometric shape?
Yeah.
Okay, so that would indicate cleavage or fracture.
Fracture?
So fractures can be irregular, where it's kind of more lumpy than it is along a plane. So plane means that you can actually draw straight, some sort of straight lines or shapes. So see how it's kind of like a little bit more angular?
Yeah, down at the bottom.
So that will be cleavage. Let me see if I can find some. Because mica kind of comes off in sheets. So you get like these very distinct sort of shapes. It's not like lumpy, it's more like a regular breakage.
Okay.
So I know it's kind of hard to see in the lab, but that will be cleavage. All right, so we'll reset this guy. I think that's it for our mica. Now we got quartz. So we'll go ahead and do our scratch test. So did talc do anything?
No.
Let's see if our handy dandy disembodied fingernail does anything. Did that do anything?
No.
Next is our penny. Did that do anything?
No.
No. Put our nail. Did that do anything? Did the nail do anything?
No.
No. Okay. And so next, I think, is our glass. Did the glass do anything?
No.
Nope. Did the streak plate do anything?
No.
No. So let's try our topaz. Did that do anything?
It left some marks on it that count.
Yeah.
Yeah.
So it sure did. So for topaz, its hardness is going to be less than 10 because that's what a diamond is, but it's going to be more than our streak plate, which is 5.5. So that if I am to look up topaz, it has a hardness of 8. So that means quartz is going to have a hardness of less than 8.
Okay. Okay.
So for streak or quartz, ooh. Are you able to see any distinct color?
No.
Okay, so you'll say colorless for its streak. So in terms of luster, does she look like she has metal in it?
No.
No. So you'll go ahead and say non-metallic. Doesn't look as shiny as, say, like our calcite or mica. So you could probably say it's a little bit more dull.
It's non-metallic, right?
Mm-hmm. It's non-metallic. If I put a magnet next to it, does she move?
No.
If I put her next to my iron filings, do those move?
No.
No. So quartz will be non-metallic. Or sorry, non-magnetic.
Okay.
All right. And then let's drop some acid on this guy. Did anything happen when I dropped acid?
No.
No. It's pretty Lackluster. Get it? Do you get it?
Yeah.
Okay, so now we'll try and check out our breakage. If I can get this to work. This is like the trickiest one out of all the tests to get to line up. Okay, so let's check out this guy. So does she look like she's regularly breaking along like a plane, like straight lines?
Yeah, in the middle, right? Right in the middle.
In the middle, it does look that way. It's kind of tough to see. So let's see. Let me see if I can find you a good picture of. Okay, so yeah, you can see that we do have some planar breakages. So you can probably say cleavage for this guy. Put quartz back. Next, we'll do sulfur. So let's check out sulfur against talc. Did that do anything?
No.
No, absolutely not. Let's see if fingernail will do anything. Ooh. So that definitely was able to scratch it. So this shows that our sulfur mineral is going to be a hardness of less than 2.5.
Okay.
So greater than 1, but less than 2.5. So that's going to put us in that range.
Is that for the hardness?
Yes, for hardness. So you'll say it's a range between 1 and 2.5. Because talc has a hardness of 1 and the fingernail has a hardness of 2.5.
Okay.
And so the fingernail was able to scratch it, but the talc was not. So this guy is kind of in that range.
Okay.
So do the streak. All right, can you see anything?
No.
No. So you'll say colorless streak. And the thing to keep in mind is if we maybe had a different color streak plate, that our streaks might look slightly different. So I'll tell you right now that the sulfur will have a streak on a black streak plate. So that might be a more useful streak to use for identifying sulfur. And that will be one of your questions.
Okay.
Streak will be the most helpful if we have a black streak. All right, so let's check out our magnetism for sulfur. So I'll put this here, my magnet next to her. All right, did anything happen with the magnet?
So non-magnetic.
Exactly, and then we'll check the finer ion filings. Did anything happen?
No.
No. So yeah, definitely not magnetic. So let's check our effervescence. We'll put some acid on there. Did anything happen?
No.
No. So she did not effervesce. So it does not mean, it means there's no carbonate within there. Okay. So now let's check our breakage. Oh, that's not what I wanted. There we go. Let's take a look. All right, so is this cleavage or is it fracture?
Cleavage. Right.
Yeah, it looks pretty, ooh, pretty plainer. Let's see if we can get a better look. Sulfur. So yeah, kind of similar to our quartz, it looks like we do have breaks happening along different planes. So we'll have cleavage for that guy. So reset, bring them back. All right, almost done. Home stretch, we're on the bottom. So we'll do magnetite. I wonder what that could have in there. So let's do our hardness test. So did talc do anything?
No.
No, so it's definitely harder than 1. Let's try our fingernail. Anything?
No.
Okay, so it's definitely harder than 2.5. Let's try serpenny. Did the penny do anything?
No.
No, so it's harder than 3. Let's give our nail a shot. Anything?
No.
No, so it's harder than 4. Let's try our streak plate.
Yeah.
So it's definitely less than 5.5 on the hardness scale. I think our glass is a little bit between like 5 and 5.5, I think.
Okay.
Let me double check for glass. Yeah, glass says 4 to 7, so I would say it's probably between like 5 and 5.5 will be our magnetite. So let's bring this guy over. All right, in terms of luster, what does she look like?
Metallic?
Yeah, I would say so. It kind of doesn't show it very well here, but yeah, magnetite is definitely going to look a little bit more metallic, which by the way, did we do luster for sulfur?
No, I was just looking at that now. It was
Okay,
non-metallic, right?
let's take a look at luster for this guy.
Non-metallic?
Yeah, I would say non-metallic for her. And then for magnetite, let me show you a real life sample. I also think that's tough is with these virtual experiences, they're not going to be super realistic. So so yeah, you can kind of see this like shiny, almost iron-like bits to it. So it's definitely going to have a metallic luster. All right, Natalie, is it going to be attracted to the magnet?
I think so.
I think so too.
Yeah.
Oh, absolutely. So just for fun, we'll put it up here too. Well, let me put it up here. And did the filings move?
Yeah.
Perfect. So you'll say metallic for magnetite, and you'll say that it reacted to both the magnet and the iron filings. Okay, and then we'll do breakage for this guy. You probably could tell by the Google search I just did, but we'll do this.
Cleavage. That'd be cleavage, right?
Mm-hmm. looks like it's breaking along a certain plane. Did we already do the acid?
No.
Okay, so let's do some acid on there.
Nothing happens.
No, yeah, nothing happens. So you'll say no for effervescence. Got 2 more?
Mm-hmm.
You're sad because you wish you could do this all day. I know for a fact.
Did we do the streak for that?
Oh, I don't think so. Let's do that.
So that's like a grayish.
Yeah, it's kind of similar to mica.
Okay.
Okay. So pyrite, I'm gonna put talc against it. Anything happen?
No.
No. So it's harder than 1.
No.
So it's harder than 2.5. Let's try our penny. Anything?
No.
It's greater than 3. Let's try our nail. Anything?
No.
It's greater than 4. Let's try our glass slide. Anything?
No.
Greater than 5. Let's try that.
No. No.
No? Okay. So it's greater than 5.5. So now we're going to get into the good stuff. Let's try topaz. Ooh.
No.
Well, it's kind of hard to see.
Yeah.
But now it looks janky. It looks messed up.
Oh yeah, I see it now.
Okay, so topaz has a hardness of 8. So that puts us in between 5.5 and 8 for our hardness.
Okay.
Let's check out our luster for this guy.
It's glassy.
It does look glassy. So pyrite is also known as fool's gold. You'll see why. So even though it looks glassy in the lab, this is what a real sample of pyrite looks like.
Oh wow.
So I would say it's going to have a metallic luster.
Okay.
Again, I know this lab isn't as good as the real thing, but it's as close as we can get. But yeah, it's called fool's gold, as you can imagine, because when people would go mining, they would see this and think they literally struck gold, but it was not. Let's try maybe streak.
Black.
Yes, my soul. So let's see if she's magnetic. Does she move towards the magnet?
Nope.
Nope. Let's see if the iron filings do anything for her. Do they move?
Nope.
Okay, so she's definitely non-magnetic. Let's drop some acid on her.
No.
No. So no to the effervescence. Let's break her and see what happens. Got this.
So it's cleavage.
Yeah, I would say cleavage. So you can tell kind of from this, but definitely from the pictures here that we do have like very sort of angular shapes that it comes out in.
Yeah.
And so that's across a plane. So yeah, definitely cleavage.
Okay.
All right. Do you think you're ready to try and figure out what the unknown mineral is?
Yeah.
You sound so excited. I knew you would be. All right, so let's do our talc. Anything?
Nothing.
Nothing. So it's harder than 1. Let's try our fingernail. Anything?
No.
Did you say yeah or no?
No.
You're correct. So it's harder than 2.5. Anything?
No.
No. So it's harder than 3. Let's try our nail.
No.
Nope. So it's harder than 4. Let's try our glass slide.
Nope.
Nope. So it's harder than 5. Let's try our streak plate.
No.
Nope. Let's try our topaz.
Yeah.
Yeah. So we know that this hardness is going to put us in between 5.5 and 8. Because it's harder than the streak plate, but it's not harder than the topaz.
What would the hardness of the diamond be?
Oh, diamond is a 10.
Okay.
She is the hardest mineral. And so sometimes you'll hear like a diamond tipped blade, right, or saw, and that's because it has the highest hardness. So people use it to aid in like construction and cutting down materials because she's tough. She's rough and tough. All right, so let's check out our streak for this unknown guy. Anything?
No.
No, so you'll say colorless streak. Let's check out her luster. So metallic or not metallic?
Metallic. No, non-metallic.
So yeah, I'd say non-metallic. Again, I know it's kind of hard to see. Yeah, I'll say non-metallic. Let's see. Is it magnetized?
No.
No, she is not feeling attracted to that magnet. Let's see if the iron filings do anything.
No.
Nope. So definitely not magnetic. Let's check out our effervescence.
No.
Nope. And then last but not least, let's check out our breakage.
Cleavage.
I would say,
No refraction because it's going down, right?
yeah, it looks kind of angular. So I would say, yeah, that's cleavage. So what you'll do is you'll check out our chart at the very, very, very end after you've filled in the info for this unknown.
Did we do the streak?
Yes, that was colorless.
Okay. I gotta fill it in. Okay. So the chart at the bottom?
At the very, very end.
Okay, yeah.
Number 18.
Okay.
So what might be the most helpful indicator in identifying this mineral?
Quartz.
What was that?
Quartz.
Oh, yeah. You got it.
Okay.
So yeah, I would definitely identify it as a quartz because the color varies, which works for us because this is kind of like a pinkish. It has a glossy luster, which, you know, sure, it's kind of hard to tell again under this light, but it's definitely not metallic, I would say. It has a colorless streak, and then it is classified roughly as hard. Okay, so that means it has a hardness that's more than 5, which we know for a fact because it's in between 5.5 and 8 on our hardness scale. And so to answer number 18, you're just going to say exactly that. I believe it's going to be quartz because of these reasons. And you'll say it's definitely not diamond because as you look at diamond, it has the same exact characteristics as quartz. But we know in terms of hardness, it is at the very, very, very end of the scale.
Okay.
And so what we have here is definitely not diamonds because if it was, nothing would scratch this except for a diamond.
Okay.
But because it is scratched by something softer, that means it cannot be diamond.
Okay.
So that's how you answer that question.
All right. Thank you. All right. Is that right? So now I just have to answer the questions at the bottom?
Yep.
Okay.
Do you have any questions for me specifically?
No, I think I'll be okay.
Okay. So I'll send you the new code for the quiz. And so you can take the quiz whenever, as long as it's before Friday.
Okay.
As soon as you start the quiz, you have 2 hours to finish it. So it's 30 multiple choice questions. And if you did the study guide for it, you're going to be in pretty good shape.
Okay.
But yeah, let me know if you need help with anything else. And of course, if you need some extra time for the work from this week.
So it's fine. I'll be able to have a lot of free time.
Same. But if that changes, let me know. I understand these are really strange times. And so yeah, if you need a little more time on this week's work, just let me know.
All right. Thank you.
You're very welcome, Natalie. I hope you have a good day.
You too. Bye.
Thank you so much. Bye.